Hello, madam, am I audible?
Yes, yes. Just say that I'm Dr. Singh.
Thank you so much, MUHS Nashik,
One
for.
second, she'll just introduce you, Dr. Singh.
Okay.
Bolo.
Yeah,
Thank you.
afternoon to you all. I am Major Dr. Singh, the professor from Department of Pharmaceutical Medicine. And I am glad to say that today we have with us Dr. Rashmi V. Udanwadikar. She is working as a professor in Department of Mechanical uh, Engineering at VNIT Nagpur. She holds an additional responsibility of Associate Dean Public Relations. She has 26 years of teaching and research experience. She has supervised 10 doctoral and 34 master's students, out of which 7 students have been awarded PhD and 3 are still working. She has 5 granted patents to her credit and more than 40 papers published in international journals of high repute. 7 papers authored by her have won Best Research Paper Award in conferences till now. 3 books and 2 copyrights are published by her so far. She was felicitated as an Inspiring Women Research Awardee in 2014 and Women Innovator Awardee in 2019. She is the founder director of a startup named NU OSA Medi Equip Private Limited, which manufactures academic dissection models for ENT surgeons. Over to you, ma'am. We are really happy to have you here, ma'am. Thank you.
Thank you so much, sir, for this kind introduction. We had a very fruitful interaction with Vice Chancellor Madam, and I really feel blessed to share my research. So this is just a highlight of the research. So till date, in the biomedical engineering field at VNIT, we have done almost 40 plus research projects. Some of them are with the dentists, then orthopedic surgeons. We have worked with ENT surgeons, nephrologists, and many more. So some of the projects I'd like to present here before you. Seeking blessings from Almighty God, when I study about the biomechanics of either a musculoskeletal system or a tooth or a bone, I always wonder, this Almighty God, he must be a mechanical engineer. He must be an engineer first to design this body, which is a wonderful and a marvelous design. Everything is so well placed in a small, compact space. You have lungs, you have heart, you have rib cage. Everything is so well protected. But then we definitely need a doctor so that we keep going for as long as we are alive. And so it's so important to join hands between engineering and medical sciences so that we continue working and use fully or with the full utilization of the world that Almighty God has created for us. So I'm starting with the ENT research that we have done. So we have tried to manufacture indigenously the nasal implant, which is used for the cosmetic surgery. This project is the brainchild of Dr. S.N. Lule, ENT surgeon from Nagpur, who was an ex-professor at IGGMC Nagpur. So to give you a brief introduction, who needs a nasal implant? This is a kind of prosthetic surgery and a cosmetic surgery used for the patients with saddle nose deformity. So you can see the images before the treatment. You can see the shape of the nose. This has a saddle nose. And after the treatment, which is the placement of the nasal implant, immediately you can see there's a lift in the nose, which gives the prominence to the face. So what is the issue? The issue is these surgeries are very expensive. They're expensive because the implants are imported. Secondly, the implants which we are importing, they are made for European population and American population. So at times they are not fit for Indian nose or for Asian nose. So either the doctors, they have to stack one over other, or at times they have to chamfer it, cut it, thin it to make it suitable for our population. So we started working on this project right from designing the implant, then manufacturing the implant, testing the implant. So we were wondering which material we should be used. And we came across this liquid silicone rubber implant, which is FDA approved, ISO certified, totally biocompatible material. This was a project done, as I told you, in association with Dr. S.N. Lule, and was successfully carried out by mechanical engineering final year BTech students. So they started with the solid model of the implant. So this was done based on the Indian nose shapes. So this is the solid model which was created initially in the software. And then we manufactured the die. So this is made in a medical grade stainless steel. And then I'm showing you some of the photographs of manufacturing the implant, which was done in the lab, in the VNIT lab. By mixing part A, part B, various steps of manufacturing wherein you can see my BTech students. And surprisingly, we came out with a near perfect implant, absolutely defect free. And the doctor was extremely surprised and happy to see that it is at par with the import class implant. And so we got this wonderful implant ready at our place. We presented this in a Singapore conference. We handed over the set of such implants to the surgeons, the plastic surgeons, and ENT surgeons. We wanted them to use these implants, give us a feedback, and in case there is a need, we can improvise this. We have presented this at different exhibitions, hackathons, and we also won first prize in one of the Indian medical device exposition in 2016 at Pune. So this was one of the successful projects. We are now looking forward to somebody who is ready to commercialize this product. So somebody can buy this technology, go for mass manufacturing, and reach to the masses. So there are projects which when we came across, we thought it is near impossible. How are we going to design something, manufacture, get the approval? But it was made possible by our creative students. So till here, whatever we have done, we have made impossible to possible. Here onwards, reaching to masses, to the doctors, to the users, getting the FDA approval is for us like a Chandrayaan mission. Extremely difficult, but yes, if India can successfully launch a Chandrayaan mission, then definitely you and me, so doctors and engineers, we can also make this from impossible to possible. On a similar lines, we have manufactured, designed, developed a 3D printed temporal bone for the academic dissection model. We are also started mass manufacturing so that we can provide this to the doctors, to the PG students from ENT. This is our team. We have worked together in this design and development. In our team, we have 2 ENT surgeons, our own MTech student who has worked on this project. He is continuously into design and development, and we have a quality partner also. So this is our team. What we are doing here. So after designing and developing, we found that there is a limited availability of cadavers. The surgical training programs are very expensive, and there is a need for the trained surgeons. And so to address all these needs, we have this academic dissection tool, and we can provide simulation training to the ENT surgeons. And we just had a discussion with Vice Chancellor Madam, and she has agreed to give training to the tutors. So that would be a TOT kind of program. So here we have developed a adult healthy model of a temporal bone, pediatric healthy model of the temporal bone. Similarly, the pathological model with tumors, with some kind of defects, and the pediatric pathological model. So we have these 4 models ready for the students of PG who can do their training. So they can get accustomed, so they'll be expert when they come out in the field. They can start working on the patients with confidence. On the similar lines, we are also in the process of developing an artificial ear model, a nose model, neck model, and a base skull model. So we are trying to expand our reach and the wings so that more and more students are getting benefited from the research that we are doing. So it's a wonderful combination of a research being done at engineering institute and then being used at a medical institute or in the medical universities. So let me move on to some of the dental projects. You would be wondering what this celebrity Madhuri Dixit is doing on my screen. So let me tell you, I'm a big fan of hers. So what? So why she is here? So she is a brand ambassador of one of the jewelers, I guess PNG Jewelers. So every time I look at her image, and I feel that if I buy this kind of jewelry, I'll also look like this. Then I realized it's not about the jewelry, it's about the happiness that she is carrying on her face, the confidence that she is carrying on her face, which is tempting me or which is attracting me. So, what makes us happy? What is that is inspiring? What is that is so inspiring? So, based on this, we made a research project again in collaboration with an orthodontist from Wardha. She said, Madam, we are happy if we are comfortable. And we are comfortable if we had had a good night's sleep. But if the person sleeping next to us, if he or she is snoring, you cannot sleep comfortably. Maybe the is sleeping comfortably, but not the partner over there. Yes, so can we have a device which will control this snoring? So one who is snoring also has so many health risks associated. They have long interruptions in breathing. They wake up very frequently from sleep because of the noise from the snoring. It also puts a strain on the heart because the breathing is not normal. It indirectly leads to obesity also. Now, there are various reasons why a person snores. One of the reason is malocclusion. So all the dentist friends would know class 1 malocclusion is a normal occlusion where the upper jaw is little ahead of lower jaw. A class 2 malocclusion is when an upper jaw is very much ahead of the lower jaw or the lower jaw is retracted. As a reason, when they lie in the supine posture on their back, their tongue tends to fall back and which leads to choking of windpipe. So the moment they lie down, their windpipe is like choked, like a pressed pipe. And every time they are breathing, it comes with a noise which is nothing but snoring. So what can be done? Can we provide or can we give them a device which they can wear, sleep comfortably without snoring? So yes, it's possible. And there are devices available in the markets. Now, there are two types of devices. One is the devices which are available at low cost, but not very comfortable to wear. How can a person wear something which is not comfortable and go to sleep? Or there are high-end devices, comfortable to wear, but then again, just because it's too costly, nobody is really bothered to buy those. So we want a device which is comfortable, easy to wear, and we have done number of iterations, and this was our final iteration in which there is a small stainless steel pin showing the shape as shown in this first image, and this is holding the low. And it gets its reaction from the upper jaw. So all that the patient has to do is wear a part of acrylic sheet, SX sheet in the upper jaw and the lower jaw and just put this pin. This is not very rigid, it is flexible, so the patient can have little flexibility of moving the lower jaw. It's very comfortable to use, no sharp edges. And when the patient is wearing this, whole night the lower jaw is pulled forward and so there is no snoring. So this was a device which we developed at VNIT, and then so the dentist who was working with us, she got approval, ethical approval for the clinical trials. You can see the patient who is wearing the device. Look at the image before the device and after the device, and you can appreciate the lower jaw is pulled forward. after wearing the device. Same thing we have tried to cross-check using the X-rays. First image of the X-ray is showing the person without device with malocclusion. Second X-ray is showing the person wearing the device with the lower jaw pulled forward. And the windpipe is wide open. So he can sleep comfortably, breathe comfortably without snoring. So this was another project. And believe me, when I presented this in one of the platforms in a Rotary Club, next day there were two Rotarians at my home. They said, "Madam, we need at least 4 such devices." And I said, "I'm so sorry, we are only into research. We are not into business. So I want somebody to pick up this technology. I'll give you all the details. You start manufacturing, make it available on the shelf. Cost is as low as 600 rupees. So you can still have some profit, sell it at 800. Everybody is benefited." So this was our second project. Third project, moving on to another dental project. This was a DST funded project. Way back in 2016, we got around 50 lakhs for this project. So the project was about the digital dental restoration system. And you can see there is an image of the Mars mission. I'm sure all of you are aware that this Mars mission took 450 crores, which is a very small budget as compared to the NASA budget. Tom Cruise movies, Mission Impossible, the budget is 1250 crores for one movie. Whereas our mission to Mars, this was achieved just in 450 crores. So this is possible because we Indians are so well programmed to manage within the available resources. That is what we are trying to do here. So looking at what is the dental restoration system available traditionally, and then we'll see what is the digital modification. So this was done with a team of doctors, dentists from Government Dental College. This is my team with me on this project. Dr. Darshan Dakshindas from GDC, Dr. Vinay Hazare, Dr. Harshvardhan Ari, these were some of the leading pillars of this project. So as you are aware, all kind of prosthodontic treatment where a dental crown is prepared, this is done using the conventional investment casting, wherein the tooth is prepared, an impression is taken. By pouring the metal or by preparing it from ceramic or porcelain, a crown is prepared. Now, since this is done in a conventional method of casting, it has a lot of inaccuracies. So either the crown which is prepared is little oversized or little undersized. So there are errors at the impression stage, there are errors in the casting stage, errors at the finishing stage. And this treatment requires maybe 2 or 3 settings of the patient. Can we replace this? So yes, this can be replaced using a digital technique. Instead of taking an impression, we can take an image using the intraoral camera. Instead of casting it in the dental lab, it can be designed on the screen. And then again, by replacing the casting by tabletop milling, which is very precise and accurate. This can be done in single sitting. So patient comes in, the doctor prepares the tooth, scans, creates a CAD model. Within 40 minutes, this milling is done. Within 1 hour, the entire treatment is over and patient can go home happily. Now, such kind of digital techniques, the CAD/CAM techniques, they are available in Germany. It's available in Italy. But what is the cost? The cost is around 70 lakhs. So I am probably quoting the rate from 2016 or 2017. So to today, I'm sure it must be plus 20% or plus 30%. So like the Mars mission wherein NASA has already reached Mars. Why India wants to go to Mars? Likewise, if this technique is already available by German technology, why India is doing the same thing again? So the Mars mission, the concept of Mars mission itself, I recall something. A German delegate, they came to India and they said, why are you spending so big amount on the Mars mission? Instead, why don't you build toilets? India, still the toilets are not available. Why don't you build toilets instead? And somebody answered, yes, we are building toilets also, but we are also showing the next generation of India that yes, we can do the Mars mission as well within the limited resources. So that is trying to hold the next generation to India. Everybody is going abroad. It's a huge brain drain. Likewise, we want to show to the next generation that yes, this kind of digital dental restoration can be done very much in India. So we started working on this DST funded project. So this intraoral scanner was procured. We created the CAD model. We developed a software in which the library of different types of tooth, right from incisors to canines, premolars, molars, upper jaw, lower jaw, pediatric, adult, all sizes, all dimensions. We created a library. We created the CAD model of all kind of teeth. And then we also did the analysis. What would be the strength if the thickness is less or if the thickness is more? So this feature was missing in whatever is available around the world. So we added one more feature that we do a CAD, which is designing, then we do CAM, which is machining and manufacturing, and we also do the CAE. CAE is computer aided engineering. So we also apply load and check at what load it fails and whether it is strong enough to sustain the biting force. And it was successful. So we tried to create the crown using 3D printing. We tried to create it using milling. And we tested this on patient in one of the dental clinics and it was successful. So that was another successful project in the area of dentistry. We completed this the year 2018-2019. Moving on to another project. If you can see an image on the screen, he is A.V. Hill. I'm not sure how many of you have heard about this gentleman. A wonderful gentleman. Why wonderful? He was a mathematician who studied mathematics, but he was so much, enchanted and enamored with the medical sciences that he started studying the physiology. And he did a lot of research in physiology and he got Nobel Prize for physiology. This was way back in 1922. So if a mathematician can get a Nobel Prize in physiology, it is that interesting, or there is a deep connection between the basic sciences, engineering, and medical sciences. So the only attempt or the only expectation from this research is to bridge the gap between engineering and medical sciences. So on a similar lines, another small step towards improving the surgery is creating or designing the osteotomy forceps used for rhinoplasty. This was a BETIC funded project, again in collaboration with Dr. S.N. Lule, the ENT surgeon. Rhinoplasty is a nose surgery in which conventionally a chisel and hammer, what they call as osteotome and hammer, is used for cutting the bone. So the issue is because it is a chisel and a hammer, there is an impact loading. And this impact loading is extremely painful. Even 1 month or 2 months after the surgery, the patients are complaining of pain. Second, because this is a cosmetic surgery, everything is done below the skin. So it is kind of blind. So doctor is unable to see exactly which part of the bone is being cut. And then there is an uneven cut. So this is a very skillful surgery, which very few doctors or surgeons they are attempting. These are some of the images of the conventional technique. So Dr. Lule came up with an idea, can we replace this conventional chisel hammer with a kind of forceps in which there can be a gradual loading and then can be a clean cut. And we said, yes, let us try doing this. And we started working with the forceps models. We realized that a lot of force is required for cutting this bone. And so we use the concept of lever, wherein with a longer effort arm, the effort can be reduced. Then, since the nose shapes are different, we wanted a universal forceps, a single forceps, which can be used for a variety of nose shapes. And so we thought of using a 3-piece model, wherein the first part is inserted, then the second part is inserted, and then it is locked. So there is a locking pin. So after having designed, created the 3D printed prototype, approved by the doctor, we created a metallic stainless steel forceps, which can be autoclaved. And then we wanted to test this on the cadavers, on the dead bodies. So we visited, we got the permission from the medical colleges, and this was one of the first trials on the dead body. We as an engineers, we are really afraid of dead bodies and surgeries. But yes, we did this. So in our first trial, we realized that our forceps is perfect, but our locking pin was weak. And so we modified our locking pin, again tested on next cadaver. So every time we were getting some input that it needs some curvature to cater to various nose shapes. Our third cadaveric trial was quite a success, and we got a clean cut of the bone. And then we manufactured this as a finished product. When we presented this project in one of the BETIC meetings, a guy from some surgical company was very much impressed, and he said he is ready to buy this technology. He is now commercially manufacturing and selling these forceps. So we are the inventors of the patent. We have the patent, and we have given the license for manufacturing to this company. So this was the technology transfer from BNIT to a commercial company. We presented this at various platforms. The image is too small, but if you can appreciate, Dr. Anil Kakodkar is holding this forceps and really appreciating the efforts produced by us. So he emphasizes more on development. He says, I want research, but in R&D, the development and deployment should be more a focus. You do your research, and if you keep the product in your shelf, it's of no use. So it must get deployed. It should reach to the users. Coming to next project, this is about the virtual guide which we have prepared for the total knee arthroplasty surgery. You can see an image of, what is this image? You can see an image of some fruits and some preparation for puja. So recently when I was attending one of the puja, and I heard the priest saying, Yatha millotopachara dravyahi, which means whatever is available, we'll try to manage within the available resources. That is exactly what we are doing. So with whatever resources are available, whatever facilities we have, we try to come out with the products and with the ideas. So what is total knee arthroplasty? I need not explain here. We have all expert doctors over here. So in a total knee arthroplasty, there is a need to cut the eroded bone. And after the eroded bone is cut, it is replaced with the implant. So the video is self-explanatory. All that is required is a clean cut of the bone. So you can see how it is drilled inside the bone after removing the eroded part. In the femur and then in the tibia, the implants, they are placed, one implant